Good morning all. In today's class, let us look at the proof for case C. So case C was if the roots M1 and M2 are conjugate complex but not pure imaginary, then the critical point 0, 0 will be expired. So we had this linear autonomous system dx by dt equal to a1x plus b1y. Then dy by dt equal to a2x plus b2y. Then from this we will get the auxiliary equation as, so auxiliary equation is m square minus, so we will be getting a1 plus b2 m plus a1 b2 minus a2 b1 equal to 0. So as we know that the roots are conjugate complex, that means your discriminant must be negative. നമുക്ക് complex roots വരുന്നത് discriminant negative ആവുകയാണ്. So therefore the discriminant, now discriminant is given by, so d will be, so that will be d square minus 4ac. So we will get a1 plus b2 whole square minus 4 a1 b2 minus a2 b1. Now this can be simplified as, so this will be a1 minus b2 whole square plus 4 a2 b1. So this is a value of discriminant, that must be negative. Now as we know this is always greater than 0. അപ്പോൾ ഈ whole term negative ആണെങ്കിൽ, so that implies d a2 b1 must be less than 0 for d to be negative. Now if you have a product of the form a2 b1, it will be negative if a2 and b1 are of opposite signs. So this implies a2 and b1 are of opposite signs. So then only it can be negative. So we will be using this later. And now when you have complex roots for the equation, so we have taken the roots in the form. So let's take the roots to be, let the roots be of the form a plus or minus ib. So here it is not pure imaginary, a cannot be equal to 0. Now when this is the form of roots, so the general solution is, so x of t is e raised to at into, so we will be getting c1 a1 cos bt minus a2 sin bt plus c2 a1 sin bt plus a2 cos bt. So that comes from the general theory of finding the solution, and yt will be e raised to at c1, so we will be getting v1 cos bt minus c2 sin bt plus c2 into b1 sin bt plus b2 cos bt. So this will be the form of general solution where a and b are definite constants. These are constants, and c1 comma c2 are arbitrary. So a and b in some fixed numbers ആയിരിക്കും, and c1 and c2 will be arbitrary constants. So a and b will be fixed constants and c1 and c2 will be arbitrary constants. Now first let us assume the case where a is less than 0. So when a is less than 0, so the entire term here is multiplied with e raised to at. X of t e raised to at into this term and in y of t also you have e raised to at into this term. So when a is less than 0 as t tends to infinity, x tends to 0 and y approaches to 0. So all paths approach 0, 0 as t tends to infinity. So therefore all paths approach the origin as t tends to infinity. Now we will now prove that the paths do not enter the point 0, 0 as t tends to infinity, but they will be going in a spiral manner. So our aim is to prove that the critical point is a spiral, so it must not enter your origin. So it must, so it will approach but does not enter the origin. So that is what we are going to prove. So we need to show that paths do not enter the point 0, 0 as t tends to infinity, but it will wind around in a spiral-like manner. So that is what we need to prove. Now to prove this result, we will introduce the polar coordinate theta, and we will show that along any path d theta by dt is either positive for all t or negative for all t. So let us take theta equal to tan inverse of y by x. May നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ ചെയ്തതാണ്. So we can take tan theta equal to y by x and upon differentiating with respect to t, we will be getting this equation. So, tan theta differentiate ചെയ്യുമ്പോൾ 1 plus 6 square theta d theta by dt വരും. എന്നിട്ട് നമ്മൾ 6 square theta നായിട്ട് replace ചെയ്ത് നമ്മൾ ചെയ്തതാണ്. So we will be getting this differential equation. So d theta by dt will be equal to x dy by dt minus y dx by dt by x square plus y square. Now we know the values of dx by dt and dy by dt from the autonomous system. So substituting that, we will be getting d theta by dt equal to, so upon simplifying we will be getting a2x square plus b2 minus a1 xy minus b1 y square by x square plus y square. Now we are interested only in solutions that represent paths. So we assume that x square plus y square is not equal to 0. So we assume x square plus y square not equal to 0. Now since okay, also we know that A2 and B1 have opposite signs. So we will be using this now. Okay. Now since they have opposite signs, so let us consider the case in which A2 is greater than 0 and B1 is less than 0. So let A2 greater than 0 and B1 be less than 0. Now then y is equal to 0, we will be getting d theta by dt equal to, so y equal to 0 വരുമ്പോൾ ഈ രണ്ട് ടേം 0 ആവും, ഇവിടെ x square വരും. So that will be a2. Since we know a2 is greater than 0, so in this case d theta by dt is greater than 0. അപ്പം നമ്മൾ പ്രൂവ് ചെയ്യാൻ പോകുന്നത് ഒന്നെങ്കിൽ d theta by dt പോസിറ്റീവ് ആണ് അല്ലെങ്കിൽ negative 1. So that means theta will be constantly changing as t varies. So theta positive and negative ആണ്. അതായത് തീറ്റയുടെ വാല്യൂ ഫിക്സ്ഡ് ആയിരിക്കില്ല. പോസിറ്റീവ് നെഗറ്റീവ് ആകുമ്പോൾ that means theta will be constantly changing. So therefore we can conclude that the curve will be changing in a spiral-like manner. So it will be taking both positive and negative values. Theta എപ്പോഴും change വരുന്നത് t varies. So it will be changing in a spiral-like manner. So we have got when a2 is greater than 0 and when y is equal to 0, d theta by dt would be greater than 0. Now let us look at the case where y is not equal to 0. So when y is not equal to 0, then in that case also d theta by dt cannot be 0. Now let us assume the case where if it was 0. So if d theta by case namukkoru contradiction varum. So if d theta by dt equal to 0, so that will imply, so we will be getting a2x square plus b2 minus a1 xy minus b1 y square equal to 0. Now since y is not equal to 0, so നമ്മൾ throughout the y square വെച്ച് divide ചെയ്യുമ്പോൾ we will be getting x by y whole square plus b2 minus a1 x വരും, sorry y square വെച്ചാണ് വരുന്നത്. അപ്പോൾ y വരും ഇവിടെ minus b1 equal to 0. Now this is a quadratic equation in x by y. So it will be equal to 0 for some real x by y. Now if this is equal to 0, when you take for some real xy, it must be equal to 0. So that means your discriminant must be positive അല്ലെങ്കിൽ equal to 0 ആണ്. ഇനി ഇതിന്റെ discriminant എടുക്കുമ്പോൾ that will give us b2 minus a1 whole square plus 4a2 b1. Now that discriminant is negative. നമ്മൾ ആദ്യമേ ഈ roots a plus or minus ib roots ആണെങ്കിൽ it must satisfy this condition. ഈ discriminant negative ആയിരിക്കണം. Now this will be 0 provided only if the discriminant is positive, so which is not possible. So for some real xy, but here d is negative, so therefore we get a contradiction. So therefore d theta by dt cannot be 3. Therefore we will get that d theta by dt is always positive when a2 is greater than 0. So we can make this conclusion. So therefore d theta by dt is always positive when a2 is greater than 0. Now similarly we can show that d theta by dt is always negative when a2 is less than 0. So similarly d theta by dt is always negative when so we have another case. The നമ്മളെടുത്ത case a2 greater than 0 and b1 less than 0. Now in the opposite case is when a2 is less than 0. So in that case d theta by dt is always negative. So therefore x and y change sign infinitely often as equal to infinity. So therefore all paths spiral in the origin in, so it can be either clockwise direction, so So clockwise direction happens when A2 is less than 0 or